Hello students, today we're going to learn section 11.3, solving systems by elimination. The word coefficient means the number next to the variable. So again, the word coefficient means the number next to the variable. When we solve systems by elimination, what we're looking for are opposite coefficients. Again, we're looking for opposite coefficients. So in example 1, it says solve and state the behavior of the lines. So again, in section 11.1, we solve systems by graphing. 11.2, we solve systems by substitution. So in 11.3, we're going to solve systems by elimination. So what we're looking for is we're looking for any opposite coefficients. So here's a -2, +3. One negative, one positive, but the coefficients are not the same. Here we have a +1 and a -1. This right here, this is what I mean by opposite coefficients. Coefficients are the same number with opposite values. So a +1, -1. So when we combine the system, 1 minus 1 is 0, so the y's are eliminated. That's why we call this the elimination method, because we're eliminating a variable. -2x plus 3x is 1x. 3 minus 2 is 1. So x equals 1. After we do that, we're going to substitute this value back into one of these equations, because we have to now find y. Now the equation I prefer to work with is this top equation. The reason why I prefer to work with this top equation is the coefficient of y is positive. So when I rewrite the equation, -2 parentheses 1 plus y equals 3. Now we just have one variable, one equation. So this is now -2 plus y equals 3. Add 2 to both sides. We have y equals 5. So we found y, we found x. So now let's write our statement. The solution is 1, 5. So that means there is one solution. Therefore, L1 intersects. Intersect means to cross. Intersects line 2. That is your complete answer. And again, this is called the elimination method. Reason, we eliminate the variable. We eliminate one of the variables, x equals 1. Substitute 1 wherever you see an x in this equation. Solve for y, so there's our solution. Example 2. So again, let's analyze what's going on here. Here's the -5, a +5 of the x value. Well, this is it. We're going to combine these terms. -5 plus 5, that's going to be 0. 1 minus 3. Remember, you don't see a number there. The coefficient is 1. 1 minus 3 is -2y. -3, -1 is -4, because the signs are the same. From here, we divide by -2. Divide by -2. Y equals -4 divided by -2 is +2. So we have our y. Now I'm going to substitute what we got for y into one of these equations. Since we're solving for x, I prefer to use this equation here, because the coefficient of x is a +5. I'm trying to avoid negatives. So we have 5x minus 3 parentheses equals -1. So if we look at this equation, I'm going to replace 2 wherever I see a y. So similar to what we did in the last section. This is now 5x minus 6 equals -1. Add 6 to both sides. 5x equals 5 divided by 5. X equals 1. Well, we just found our solution. It's going to be x value first, 1, 2. That means we have one solution. Therefore, L1 intersects L2. All right, that's example 2. So again, the key is look for opposite coefficients, and that's the variable we're going to eliminate. So now if we look at example 3, the coefficient of x, -3. The coefficient of x here is 2. We have opposite signs, but the coefficients aren't the same. We have +4, +1. So the easiest one probably to, well, what we could do is we could multiply this by, if this is 4, I need to make this -4. So I'm going to multiply by -4. When I multiply by -4, this is -8x when I distribute. -4y equals 32. I'm going to bring this equation over. I'm not going to change anything. The reason why is when I rewrite this equation, you're going to notice what variable we could eliminate. So the variable we could eliminate will be the y's because we have opposite coefficients. 4, 4, one's positive, one's negative. So that means when we add everything, -3, -8, -11x. That's going to be 0 equals 44. 2 plus 2 is 4, 1 plus 3 is 4. To get x by itself, we divide by -11. X equals -4. Okay, so now we have to look for the y variable. What I'm going to do is I'm going to rewrite this equation here. 2x plus y equals -8. Now what I'm going to do is I'm going to substitute. Wherever I see an x, I'm going to put a -4 in this equation here. So this is 2 parentheses y equals -8. Again, what do we put in for x? -4. So this is now -8 plus y equals -8. To get y by itself, we add 8 to both sides. So y is equal to 0. Well, now that we have a value for x and we have a value for y, we could write our conclusion here. -4, 0. That means that is our solution. We have one solution. And that means the two lines intersect at this point, like what we did in 11.1. Therefore, the behavior of the lines L1 intersects L2. So that's the solution, that's the behavior of the line. Alright, example 3. Oh, I'm sorry, example 4. Let's take a look at this problem here. So let's analyze which variable would be easiest to eliminate. Well, here's a +3, -6, -2, +4. So we don't have any matching variables, if you will, or matching coefficients. But if I multiply the top by 2, 2 times 3 is 6. Well, that's good because we want a positive 6x. So 2 times negative 2, negative 4y. 2 times 4 is 8. Rewrite this equation here. Negative 6x plus 4y equals 5. I'm not changing this because I could see that we could eliminate the x's right away. So 6x minus 6x, well, that's 0. Oh, but I notice, negative 4y plus 4y, well, that's 0 also. 8 plus 5 is 13. Okay, so if you remember, when we have a step that doesn't have any variables, we have to check, is this a true or false statement? This is a false statement. Therefore, no solution. Therefore, L1 is parallel to L2. So remember, when you don't have any more variables, you have to check, is this a true statement or a false statement? This is a false statement. 0 equals 13, that's false. That is not true. Okay, example 5. Again, let's analyze what variable is easiest to eliminate. Well, I notice positive 3, positive 8, not the same. Positive 2, negative 5, we have opposite signs, but the coefficients aren't equal. So what I'm going to do is I'm going to work with the variable that has a opposite signs. So we have a positive here, a negative here. So I'm going to multiply this by 5. And I'll tell you why. 5 times 3 is 15x. 5 times 2 is 10y. 5 times 5 is 25. So I have 10 and I have negative 5 here. Well, what if we multiply this by 2? Look what's going to happen. 2 times 8, 16x. 2 times negative 5, negative 10y. 2 times 3 is 6. Well, look what happens here. The 10y minus 10y, that's going to be 0. 15x plus 16x is 31x. Bring down the equal sign. 25 plus 6, 31. So we eliminated the y's. That's why we call this the elimination method. And what I did was I just figured out 2 and 5 could fit into what number? It could fit in 10. So 5 times 2 is 10. 2 times negative 5 is 10. So we want this matchup because 10 minus 10 will be 0. To get x by itself, we divide by 31. Divide by 31. So x equals 1. Well, we found our x. So again, next thing I'm going to do, so we have to find y now. So to find y, I'm going to use this top equation. The reason why I'm choosing the top equation is because the y has a positive coefficient, so I don't have to deal with negative. So I'm using the top here. Okay. So this is now 3. What do I put in for x? 1. Plus 2y equals 5. So this is 3 plus 2y equals 5. Minus 3 on both sides. 0. 2y equals 2. Divide by 2 on both sides. Y equals 1. Well, we found our y and we found our x. So we'll just write our conclusion here. We have one solution. Since we have one solution, the the behavior of the lines will be L1 intersects L2. Alright, so that's example 5. If you notice in example 5, we had to change both equations so that we can get an opposite coefficient matchup so we could eliminate the y's. If you look at example 4, I only have to change one equation because I knew that 2 can go into 4 2 times. So that's why I chose to eliminate the y's first. If you want to eliminate the x's, oh well, it would have been the same thing. Okay. Alright, last example. Again, let's analyze our system. -2, +5. Well, one negative, one positive, that's okay. But they're not matching coefficients. +4, -10, again, not matching coefficients. So I am going to do this. I'm going to multiply the top by 5. When I do that, 5 times -2, -10x. 5 times 4, 20y. 5 times 3, 15. I'm going to multiply this by 2 because I want to eliminate the x's. So when I multiply this times 5, -10. When I multiply this by 2, I get +10. So let's just continue to distribute. -20y equals 2. Well, look at this. -10x plus 10x. There, we eliminated. So let's see what happens here. Oh, well, 20y minus 20y, that's 0. 15 plus 2 is 17. So again, from here, we don't have any more variables. So we have to state, is this true or false? This is false. So if this is false, my conclusion is no solution. That means the lines are going to be parallel because they do not intersect. Therefore, L1 is parallel to L2. Remember, this symbol means parallel. All right, that's it for today. Have a good day.